Morning and Sairam. Welcome back to your online classes. I hope you will score very good marks in your online periodic test, and I hope you have done very great in your periodic test. So, come back to your daily routine and let us start our physics chapter. So, before periodic test, we have completed our 2 chapter of physics, force and law of motion and motion. Now, our third chapter is gravitation. What is our third chapter? Our third chapter is gravitation. See, when you will hear a name gravitation, what comes in your mind? Yes, Sir Isaac Newton. And what incident? Yes, fell of apple on Newton's head. See, so the topics which we are going to cover in this video are: number 1, introduction. We will do introduction about the chapter, universal law of gravitation, value of gravitation constant, that is capital G, gravitational force between object of small size and big size, and if we will do derivation of universal law of gravitation, at last what will come? A formula will come. So we will do numerical based on that formula. Is this clear to you? What we are going to cover? We are going to cover introduction, universal law of gravitation, value of gravitation constant G, gravitation forces between small size of body and big size of body, and numericals. Is this clear to you? So let us start with our chapter. Introduction. So, gravitation force of the earth or gravity. Clear? As we all know that a force is necessary to produce motion in a body. If you want a body to move, what you will do? You will apply force on that body. Clear? That means for motion of a, if you want to change a state of a body, what thing is required? Yes, you required force. What you have required? You required force. So, in a simple language, you can say that with the help of force, you can change the state of body. That means if a body is in a rest, if you will apply more force, that body will start moving. And if a body is already in a motion state, if you will apply force on that, our body come to rest. Clear this? So, for example, a body dropped from a height falls towards the earth. For example, your leaf. Clear? And if you will throw a ball from some height, it will comes down. Clear? And towards the earth. So it indicates that the earth exerts a force of attraction. Why it comes only down? Why it does not go up? Yes, it indicates that earth exerts some force on that object, and that force is known as your gravity. That force is known as your gravity. So I am reading this line once more. Listen carefully. A body dropped from its height falls towards the earth. It indicates that the earth exerts a force of attraction called gravity on the body. Clear this thing? So in fact, the earth attracts all the object towards the center. We all know that earth attracts all the object towards the center. So the force with which, so what do you mean by gravitational force? You can write the force with which the earth pulls the object, the force with which the earth pulls the object towards it is called the gravitational force of the earth or gravity. Understood this? What do you mean by gravitational force? The force with which the earth pulls. The force with which the earth pulls or attract the object towards it is known as your gravitational force. I think with this, gravitational force is clear to you, and it is also clear to you why all object attracts towards the earth. Why? Because of the gravitational force. We can walk on the surface because of the gravitational force. If gravitational force is not there, we can float on a space. Clear this thing? Now, a gravitational force between the sun and earth keeps the earth rotates uniform circular motion around the sun. Because of the gravitational force, earth rotates around the sun. Because of the gravitational force, moon rotates around the earth. Is this clear? Because of the gravitational force, all the planets revolves in a circular path. Is this clear to you? Now, the gravitational force of the earth is responsible. You can say that the application of the gravitational force, and you can say that some incident which occurs due to the gravitational force. You can say that some incident which can occur only due to the gravitational force. And what are they? Number 1, for holding the atmosphere above the earth, for the rain falling to the earth, for flow water in the rivers, for keeping us firmly on the earth, for the revolution of moon around the earth, etc. These are the application, or you can say are the example of gravitational force. I think with this slide is clear to you. Shall we move ahead? Now, the gravitational force between the earth and the moon causes tides. The tides which comes in the sea occurs due to the gravitational force between the sun and the earth. Now think, why tides are high during full moon and moon day? Clear? See, this is optional, but I'm explaining you. I'm reading this slide. Listen carefully. The gravitational force of the moon is 1/10 million that of the earth. Clear? But when you combine other forces such as the earth's centrifugal force created by its spin, you get tides. The sun gravitational force on the earth is only 46% that of the moon, and sun gravitational force on the earth is a 46% that on the moon, making the moon the single most important factor for the creation of tides. Now, sun's gravity also produces tides, but since the force are smaller as compared to the moon, the effects are greatly decreased. Clear? That means the force which are present in the moon is more. So when there is a full moon, more force are there, and due to this, the tides is higher in a full moon and lower in the during your Amavasya. Clear? Tides are not caused by direct pull of the moon's gravity. The moon is pulling upwards on the water. What? Moon pulls? Yes, water upwards. Now, while the earth is pulling downwards. Now, on the water, gravitational force applied from the both side, from the downwards and from the upward. From the downwards, who's applying gravitational force? Earth is applying gravitational force. And from the upward, who's applying the gravitational force? Moon is applying the gravitational force. Is this clear to you? Now, slight advantage the moon thus we have tide. Clear? Because it is upward. Whenever the moon, earth and suns are aligned, that means in straight line, the gravitational pull of the sun adds to the moon. Now, sun is also upward. Now, the gravitational force which comes from the sun is also combined with the moon. Now, to that moon causing maximum tides. That's why it causing maximum tides. Spring tides happen when the sun and moons are on the same side of the earth, or when the sun and the moon are on the opposite sides of the earth, that is full moon. Clear this? Is this thing clear to you? Now you understood how tides occurs? Yes, tide occurs due to the gravitational force of earth and the moon, and when your full moon is there, more gravitational force is there, so on the full moon more high tides are there. Is this clear to you? Now when the moon is at the first quarter or a last quarter phase, meaning that it is located at the right angle to the earth sun line, the sun and moon interfere with each other in producing tidals. Bugles and tides are generally weaker, and these are called neap tides. Clear? That means if they are half. Okay. Offshore in the deep ocean, the difference in tides usually less than 1.6 feet. The surf grows when it appreciates a beach, then tides increases in bays and estuaries. This effect is amplified. That means if sun become full, if the size of moon become more and more, that time so tides become high. Is this clear to you? Now our next topic is universal law of gravitational. What is our next topic? Our next topic is Newton's universal law of gravitation. So what is Newton's universal law of gravitation? I'm reading, listen carefully. Every body in the universe attracts every other body with a force of attraction. With a force of attraction, and that force of attraction is directly proportional to the product of their masses. If you are having two bodies, clear, so whatever force you apply is always directly proportional to the product of masses of their masses, and is inversely proportional to the square of the distance between them. Is this clear to you? I have already told you that what do you mean by directly proportional and indirectly proportional. I'm explaining once more, listen carefully. Directly proportional means, for example, if you are taking height and length. Clear? If I will say that this height is directly proportional, sign of directly proportional is this. Clear? This height is directly proportional to length. What it indicates? It indicates that if your height increases, your length is also increases. Clear? And if your height decreases, your length is also decreases. Is this clear to you? Listen, directly proportional means both will increase together and both will decrease together. And inversely proportional, if I will say length, height is inversely proportional to length, so you will represent like this. In this, if height will increase, your length will decrease, and if your height will increase, your length will decrease, and if your height will decrease, your length will increase. It goes opposite to each other. Is this clear to you? Now take two bodies, this one and this one. This body is having capital M mass and this body is having small m. You can take small m1, m2. I'm taking m and small m. The distance between these bodies are r. Clear? So first point is, every body in the universe attracts other body with the force which is directly proportional to the product of their masses. That means your force F is directly proportional to product of their masses. That means M1, M2. Is this clear to you? M1 and M2. And what is our second point? Second point is, it is inversely proportional to the square of the distance between. That means I'm taking here, take m1 and m2 then. F is directly proportional to square of distance. And what is our distance? That is r square. So this is our first equation and this is our second equation. This and this is equal, so you can equate this now. So your F is directly proportional to m1 m2 upon r square. Is this clear to you? Now I told you earlier also, if you want to remove this proportionality sign, what you have to do, you have to put one constant. So here we are talking about gravitational force, so what we will put gravitational constant. So F is equal to capital G m1 m2 upon r square. This is the formula which you will get after deriving the universal law of gravitational. I think is this clear to you? F is equal to capital G m1 into m2 upon r square. Now see here. The direction of force is along line joining the center of the two bodies. Here you will take two bodies, this and this. Wait. This and this. Mass of this is m1 and m2. The distance is r. Clear? Now let two bodies A and B of masses m1 and m2 are placed at a distance of r. Clear? From each other, let F be the force of attraction between the bodies. So, according to the first point of the universal law of gravitation, the force of attraction is directly proportional to the product of their masses. That means F is directly proportional to m1 into m2. Is this clear to you? And the second point is the force of attraction is inversely proportional to the square of distance. That means F is inversely proportional to 1 upon r square. Clear? Now F is directly proportional to m1 into m2 upon r square. This thing I already told you. And when you want to remove the proportionality sign, what you have to put? You have to put one constant. So when you will remove this proportionality sign, what will come? G will come, and this G is constant called as universal gravitational constant. Clear? I think this is clear to you. Now properties of gravitational force. What we will do properties of gravitational force. First property is gravitational force is the weakest force in the nature. Clear? Gravitation. What is the nature of gravitational force? It is the weakest force. Is this clear? Now it is an attractive force. Clear? Like your electrostatic magnetic force, they are your attractive and repulsive force. They both are your repulsive and attractive, and this gravitational force is only your attractive force. That means only they attract. They due to the gravitational force, things will not get repelled. Understood this? Second, it is mutual force. First body attracts the second body, and the second body attracts the first body. Not only Earth applies gravitational force to us, we also, that object also apply gravitational force to the Earth. Clear? It is a central force. It is a mass and distance dependent. It is mass and distance dependent. See? M1, M2 and R. Clear? It obeys inverse square rule. It is long range force. It decreases with the distance as per inverse square rule and becomes zero only at the infinite distance, like electrostatic and magnetic force. It does not depend on the medium width between the interacting bodies. there is no gravitational shielding. I think this is very easy point and everything is clear to you. I'm reading once more, listen carefully. Gravitational force is the weakest force in the nature. It is an attractive force. Unlike electrostatic and magnetic force, they are both attractive and repulsive. In mutual force, first it is a mutual force. That means first body applies force to the second body, and second body applies force to the first body. It is a mass and distance dependent. It obeys inverse square rule. Clear? It is a long range force. It decreases with decrease as it decreases as distance decreases, and it increases as the product of mass increases, and it does not depends upon the medium. Clear to you? Now, universal gravitational constant G. What is the value of the gravitational constant? The value is The value is 6.67 into 10 to the power minus 11. Now, how this units come? You know that unit of force is Newton, unit of radius is meter square, and mass is kg square. So, Newton meter per second kg inverse. Clear? The value of G does not depend on the medium between the two bodies, because gravitational force does not depend upon the medium. Now, the value of G is same throughout the universal law. Hence, the name as universal gravitational constant. That means this value remain constant throughout the life. And the SI unit of G is Newton meter square upon kg square. Clear? How it comes? See, we know that F is equal to G m1 m2 upon r square. Now you have to find the unit of this. So F is equal to F into r square upon m1 into m2. Clear? And what is the unit of m? F, it is Newton. What is the unit of radius? It is meter. But here it is radius square, so your meter square. Now m1 into m1, kg mass kg, that means kg square. So Newton meter square kg per square. Is this clear to you? Now, if two bodies of mass 1 kg are separated by 1 meter each other, then G is equal to F, because all their values become 1, and anything multiplied by 1 will get the same answer. Therefore, the universal gravitational constant G is numerically equal to the force of gravitation which exists between the two bodies of the unit mass kept at the unit distance. Unit means 1 distance, 1 meter distance, 1 kg mass from each other. This thing is clear to you? Now, gravitational force is the weakest force of all. I told you this thing earlier. If two bodies of mass 1 kg each are separated by 1 meter, then your F is equal to G. And what is the value of G? 6.67 into 10 to the power minus 11. So what is the value of F? The value of F is this. Is this clear to you? Though the various objects of this earth attract one another constant, they do not cause any visible motion, because gravitational force of attraction between them is very, very small. Is this clear to you? Imagine a situation on the earth. The objects continuously move towards each other due to gravitational force between them. When both objects are very big, having very large masses, then gravitational force of attraction between become extremely large, and you can observe that force. So the gravitational force due to the earth on the object mass 1 kg placed on ground is 9.8 Newton. This value we will do later on. The gravitational force between the earth and the moon even at a large distance is very large, and it is 2 into 10 to the power 28 Newton. Is this clear to you? Now we will do some numerical based on this. See, calculate the force of gravitation due to earth on ground. Mass of earth is itna, radius 6.4 into 10 to the power 3 kilometer, and capital G, you know the value of capital G, it is 6.7 into 10 to the power minus 11. It is not compulsory that in every question the value of G is given to you. You have to learn this value, okay? So we know that F is equal to G into M1 into M2 upon R square. We are having M1 value, we are having M2 value, we are having radius, that means we are having this thing, what, distance. So this, you know that 12 will become, now minus 11, 12, when you will solve it you will get 9.8 Newtons. I will tell you this calculation and live classes if you don't know how to solve these powers, okay? The mass of the earth is this 6 into 10 to the power 24. These all are very easy numerical. You have to just put the value and get the answer. If you are not able to solve this numerical, just message me. I will take a live session for this calculation. I think with this, today's lecture is clear to you. Thank you and have a nice day.